As you see on the board at the moment, is that we have some residue from the last class that we did, which was not with this group by names, it was not with this group, but we did topics in trigonometry. And we're going to, we have done this topic already, which is working with right angle triangle. And we are going to take a second go at that topic in order that you might benefit. So I hope that what I'm hearing is from this class here. Okay. I have no idea that they feel, yes, they would go across so quickly in terms of, because we generally have to. Now, trigonometry. What is trigonometry? Concerning the last topic in this book, it is a short topic, and we have 2 hours. So instead of doing a short topic and not have enough time to do a long topic at the end, I prefer to do the long topic first. Alright, so we get a big topic inside here. Alright, so no problem. So we are with this book, Trigonometry. And we are going to be working with first of right angle triangles. And what is trigonometry? Trigonometry is the study of and how the angles are related to each other. Right, and we find relationship or relationships very useful. In trigonometry, we always make use of what we call similar triangles. That's what I imagine. Because this is so I imagine that we'll try this one. Really right. Now, here's your question. Are these 2 triangles similar? Tell me the requirements for triangles to be similar. Yes, sir. There is somebody speaking from over here. What will cause triangles to be similar? The angles. What about the angles? Right, the angles in the triangle. All of them, we can find, for example, that this one is right angle and this one is the right angle. So, that's a part of it. But we'll have to have at least another pair of angles that are equal. And then we have them here, correct?
Yes, sir.
So, do we conclude that these two angles are equal?
Yes, sir.
Right. In any triangle that you have 2 angles, you can find corresponding angles, 2 pairs that are equal, then the other pair is automatically equal. Okay? And these are similar triangles. What else do we know about similar triangles? The ratio. Somebody was about to say something. The ratio of the sides. The ratio of corresponding sides are equal. So if we choose this triangle and we say we have a ratio like A over B, that should be equal to what?
X over.
Should be equal to? X over Y. Yes, because we have what? A over B, so we have have x over y. And because this is so, then we can have the development of trigonometry to the extent that we can use it very efficiently to determine missing sides and angles of a triangle. Now, although we're going to take a look at it in a short while, this angle is 30 degrees, this angle is 30 degrees. And what we have done here, this over this is actually called sine 30. That's actually sine 30, and that is equal to what? 0.5. So it is going to be 0.5 for this triangle, and it will be the same for this triangle. Will it be the same for this triangle? Yes or no? Good afternoon, sir. Sir, the last part of it. Okay. Sine 30 is equal to 0.5. And it's going to be the same thing here. And sine 30, all that represents is the ratio of what? This side to this side. And it will be, in this case, this side to this side, as long as the triangles are similar. The ratios are the same, and that is why we can make so many successful calculations. Now we're going to be looking at right angle triangles. Trigonometry is developed on right angle triangles, but trigonometry is not limited, as you will see, to right angle triangles alone. So take a go at your instructional manuals. Yes. Did you get an instructional manual like this? Well, I cannot hand it to you immediately. You have to just give me a few seconds. Alright. So we're going to be taking a look at, for your right angle triangles, we're going to be taking a look at how the sides are named in a right angle triangle. That's the first thing that we're going to do. For a right angle triangle, if we have a side here, common Greek letter theta. If you have an angle there, common Greek letter theta, and we have this side that is facing, this side is facing this angle. It is opposite to the angle. It is on the other side of, just like your ordinary situation if you're going downtown and you're trying to find a particular place. Or you're on the highway. Would you say that the tax office is opposite to the craft market? Yes or no? Alright, I'm going to choose two other places.
Yes.
Would you say that BNS is opposite? No, is opposite to, I'm talking about in terms of its physical location, to It's opposite to the credit union. No. Is it across from it or beside it? Montego Bay, cooperative. I heard somebody saying that it is beside it. Alright, here is this one now. Is NK Mart opposite to Burger King? Burger King. Is it opposite? What building is opposite to MK Mart? Lloyd's opposite to MK Mart. But what do we mean by opposite? On the other side of what else? Facing or opposite. So if it is facing, the side that is facing the angle is opposite to the angle. So this side is what? In this particular case? Opposite. I mean, what would you say about this one? What is this side? Adjacent. So is MK Mart adjacent to Burger King? I don't know anywhere in Montego Bay, you know. So you have to tell me. Especially food place. No Rasta. I don't know those places. And what do you call the longest side of a right angle triangle? And what is its location? Right. It is across from the right angle. And in trigonometry, we say that it is opposite to the right angle. Or we can say that it is facing the right angle. So the hypotenuse is opposite to the right angle. And this side that we have here is what? Adjacent to the right angle. Beside, alongside, adjacent, opposite, facing on the other side of. Usually the one that is opposite is away from. So that is your opposite. What if you have a situation like this? No, I'm going to cause it to be somewhat skewed. Is it that you don't have the book today or you don't have it at all? In this particular case, this angle is alpha. Which one is opposite to alpha? Which one is adjacent to alpha? Which one is the hypotenuse? Right. Before you can even start thinking about trigonometry, you must be able to look at a right angle triangle, right angle triangle, and tell which side is what we are talking about. Look up this one now. P, Q, R. Which side is opposite? There's someone said no. So which side would you say is opposite? Good. I'm hearing some very interesting answers. For example, one says R and the other says Q. Both of them are acceptable. Which angle is adjacent? Which side is adjacent? R. So it's R or Q. Before something can be adjacent, we have to have something that it is in reference to. So we cannot have something that is opposite. It can't just be opposite. It must be opposite to something. And adjacent, it must be adjacent to something. So we have to specify an angle and say that is the angle that we're talking about. So let's call this one common Greek letter. This one looks so easy. This one. Common Greek letter beta. Which one would be opposite? Which one will be adjacent? And the P will be your Alright, suppose I ask which side is adjacent to beta and someone say P, would that be wrong? I ask which side is adjacent to beta and someone says P is adjacent to beta. Is that correct or incorrect? Is acceptable? Why is it acceptable?
Because it's like similar to R is beside of
Correct. It's similar to how R is beside beta. So yes, the hypotenuse is also adjacent to beta. So if someone says this is adjacent to beta, then the person is correct. But in trigonometry, we are always talking about, when we say adjacent, we are talking about on the shorter sides. Because we reserve the longest side of the triangle for the hypotenuse. Right. So that does not prevent the hypotenuse from being adjacent to the angle. It's just that because of convention, we reserve the adjacent to on the shorter side, and of course we know that the hypotenuse is always the longest side, and it is opposite to a right angle. Alright, so what will you do now? I can't tell you what to do. You have an exercise right here to identify the sides relative to the specified angle. Page 2, those triangles. Let's go. Look in the hand on the right hand up here. No, yes. finish yet? Okay. Just one person. Alright. Upwards for the first one. Opposite to A. The opposite is what? 12 centimeters. The adjacent to A is? And the hypotenuse irrespective of the angle is? Anybody still working on this one? Relative to B, the opposite is? Adjacent to B is? And the hypotenuse irrespective? We don't have an angle here, but you have it in your instructional manual. It is this angle C. Opposite to C, facing C is? Adjacent, which is beside C, is 5 centimeters. We have?
No, sir.
Did you say no? You know what I'm going to say, right? The hypotenuse is? Yes, ma'am. 5 centimeters. So we have identified all of the sides of each of the right angle triangle. So we can move to the next step. So we must be able to identify the hypotenuse. And relative to a particular angle, which side is opposite? And which side is adjacent? If you cannot do that, then you cannot start trigonometry. Then, what do we do next? We define the trigonometrical ratios. We define the trig ratios. And what are the trig ratios? Sine and we're going to use the short forms. So, sine is equal to what? And that's going to be taken too long to write. O over H. And cosine is adjacent over hypotenuse, which is A over H. And tangent is what? O over A. As long as you write them in that order, it's O over A. Opposite over adjacent. Right? And I was explaining to the students yesterday that I don't use SOHCAHTOA. We just use them. That's where we just, yes, through our entire lives. Those who attended the school with me. We knew of it, but we never used it. But some individuals imagine that it is very useful. And I heard somebody saying that it is. It's you. Alright, let's see how useful you find it. Yes. So that is what? Sine, cosine, and tangent. Since you can identify the sides related to a particular angle, and you can also identify the hypotenuse, I am sure that you can write down sine, cosine, and tangent of the angles in the triangles that you have on page 3. Let's go. They are on page 3. No other triangle there. No other triangle is on it. This one is out of proportion. And finally, so you better write down the sine. By the time I'm finished drawing this last one, I imagine that all the students will have the trig ratios already. Let me have a show of one of those who are finished. Anybody who is not working is finished. it should be really what? Sine of A, cosine of A, and tangent of A. So this one will be sine of B, and that is equal to? Nice. And cosine of B will be? Nice. And what about tan? Let me have a short hand of those who have not finished this one as yet. Alright, so let's continue. So this one will be sine of C. I didn't hear a thing. Am I hearing anything? 48 over 50. Opposite over hypotenuse. Cos of C. Adjacent over hypotenuse, which is? And tangent of C will be? You might just do it from here, or it is opposite over adjacent. And for those SOHCAHTOA experts, let's see what you make of it when we will be solving the right angle triangles. Now, apart from knowing your trig ratios in terms of how they are related to the sides of a right angle triangle, working with right angle triangles, you also need to know Pythagoras theorem. So that is what we're going to be looking at next. Oh, I'm going to put them right here. Thank you very much. And thank you very much. And thank you very much for all of these. Into solutions, you pass those into the source. Pythagoras theorem. If we have a right angle triangle, this is your hypotenuse, and this is just another side, and that is another of the short sides. What did Pythagoras say? That the square of the longest side is equal to the sum of the squares of the other two sides. So that the hypotenuse is equal to, how do we arrive at h if we have h squared? We take the square root, we do the opposite if we want to find h, right? Opposite of square, which is what? Do we take the square root of one side, or do we take the square root of both sides? Some individuals are not sure. Do we take the square root of one side or both sides? Right. So when we take the square root of the left hand side, we have what? The square root of a squared plus b squared. So we know that taking the square root on the left hand side will have a cancelling effect on the square that we have here. And then on the right hand side we will have. Now go back to your instructional manuals and we will apply Pythagoras theorem in finding the hypotenuse of the given right angled triangles. Centimeters. So what do we say? H is equal to the square root of 9 squared plus 12 squared, which is equal to the square root of, when we square 9 we get, when we square 12 we get, when we add them we get. Is that correct?
Yes, sir.
And the square root of 225 is
15.
nice. So the other two, you will do those on your own. Let's go. Anybody finish yet? with 7 and 24? I'm going to see what you did. Maybe you added the 7 to it without squaring it. Eight is equal to the square root of? I didn't hear that. Oh, in squaring 7, one person put 14. Did you put 14? Alright. When we square 7, we get what? Right. Some individuals make a common mistake, squaring something, make a mistake and multiply it by 2. 24, when we square that, what do we get? 9 plus 6. 7 plus 4. Add another 1. 7 plus 4, 11. And you add another 1 to that is what? 12. 5 plus 1. So it's the square root of 625 that the entire world knows to be 25. And for this one, h is equal to the square root of 7.5 squared plus 4 squared. And when we square 7.5, we get what? And when we square 4, we get 8. Hope no one put 8. And when we add those together, we get what? 72.25. And the square root of that turns out to be 8.5 centimeters. And centimeters for this one too. Let me see here the calculator. I'm going to say it is nothing to reset it. Shakespeare. On. More 2. More 1. Say 1. Let's say 1. Don't use an organizer in the class or a calculator. When you go to the examination, you're going to need a serious calculator. What's that? Yes. Is that a calculator? Since when? Since when that's a calculator? I'm going to show you a calculator in 2 seconds. Alright. Now, I am sure that if you have just a missing long side, which is the hypotenuse of a right angle triangle, that you can actually do the calculations that will give you the value or the length of that long side. Also, you should be able to find the length of one of the short sides of your triangle. find the length of your short sides of the triangle. And what students do when they are solving problems in trigonometry, they invariably add the square, irrespective of which side the examiner is soliciting. So, let us go back to your favorite. A squared is equal to a squared plus b squared. And we intend to find the length of one of the shorter sides. So we need to do a bit of rearranging of that equation, transposition. So let's say that we want to find a. What do we do? What do we eliminate first if we want to find a? Some of the students cannot see. So I'm going to write it so everyone can see. If we want to eliminate, if we want to find a, what do we eliminate first? What? If we want to find a, we are attempting to make a the subject of the formula. What do you say? Eliminate b squared, right? So we are going to eliminate b squared by what? Subtraction. By so doing, we will have what? H squared minus b squared is equal to a squared. And what else do we need to eliminate? The square. And we eliminate the square by finding the square root. So h squared minus b squared, the square root of all of that is equal to a. And is that enough? Yes. Nice, man. Very nice. We do what? Right. A equals the square root of h squared minus b squared. Do not forget that when you are attempting to make something the subject of the formula, you are intending to have it as the only thing on which side? In the end, the left hand side. Right. So there you have it. And which page do we have it on? Page 4. The second set. Is that correct?
Yes, yes.
Right. So we need to find the length of one of the shorter sides of your right angle triangle. And we are going to use this formula in achieving that. So your first triangle is meters this time. I think it's B. It does not look much like a B, it looks like an H. But it should really be B. the shorter sides will be equal to the square root of, and in here that 6.5 squared minus 2.5 squared. When we square 6.5, what do we get? 42.25. And for this we get 6.25. And that will give you exactly what? Which is what you want. And nowhere of which you can find the square root without using your calculator. And that will give you, which is 6 meters. Anybody got a number greater than 6.5? Let me have a show of hand of those who are not finished with D as yet. You are not finished with D. Okay. I am sure that everyone is finished with D by now, right? Okay. When I say right, I mean it right. So B is equal to the square root of 8. Is it 8 squared? 8.5 squared minus 7.5 squared. When we square 8.5, what do we get? 72.25. And for this one, we get what? 6.25. And when we subtract, we get 16. Of which the square root is 4. So that will be 4 meters. What about this one? Anybody enjoy that one? C is equal to the square root of
2.5 squared minus
6.25 minus 2.25, which is equal to the square root of, which is equal to what? 2 meters. Nice. Now all students, close all of your instructional manuals and focus on the board. Close all of your instructional manuals and focus on the board. sense is greater than mathematics. And sometimes you should be able to just write every problem even without making a stroke on your paper. That's nice. Now, in any situation that you can write one equation with one unknown, then your problem is solved. As long as you can write what? One equation in one unknown, then your problem is solved. Now, the first triangle that we're about to solve, as a matter of fact, the one that we're solving is going to look a bit different in your book, but don't look in your book. 30 degrees, I don't like the codes. And we should have a P here. Nice. And when the passes look at little larger on the board so that you can see. Nice. Okay? What is the first thing that we can find right here? When we're solving a right angle triangle, or any triangle for that matter, anything that is easy to find, you find that first. Angle what? Is equal to what? 90 minus 30, which is equal to 60 degrees. Very nice. All the angles in a rectangle triangle or any other triangle must add to be what? 180. And this is 90, so we know the other two must add to be 90. That's yes. Alright. What do we say now? We are going to find what? Q. Now, in finding Q, you need to write what? One what? One equation with how many unknowns? One. Therefore, if you are going to find Q, Q is your single unknown. So anything that is in this diagram that you are going to put in your, something is missing. Anything that you are going to be using must be what? What can you use from that triangle? If Q must be your only unknown, you can use what? 30 degrees because it is known. What else can you use? 10 centimeters. Right. So Q is your unknown. And this is your known. And what do you say about Q? Q is opposite. Q is opposite to the 30 degrees angle. And what about these 10 centimeters? That's nice. It's opposite to the right angle. Is that good enough? It is the? It is the? It is the hypotenuse. So you're talking about the opposite and the hypotenuse. What trig ratio are you talking about? Sine. And you cannot just say sine, but you also need to say sine is equal to what? Over hypotenuse. Right. So opposite, which is what? In that case, Q over hypotenuse, which is what in that case? 10. And that's equal to sine of 30. Can you transpose that in order to find Q? And say what? Q is equal to what? We are dividing by 10 here. We eliminate this 10 that we're dividing by here by doing what? By multiplication. So it's 10 sine 30, which is equal to 10. Sine 30 is what? On your calculator in your books. 0.5. So Q is actually equal to what then in the final analysis? 5 centimeters. Okay? 5 centimeters. What else do we need to find?
P.
P. We need to find P. And what do we use in this particular case in order to find P? What are the nodes there? How come? The hypotenuse is known. What else is known? I didn't hear that. This one is known to be what? 5 centimeters. And what else is known? Pretty much everything else because this is 60 degrees, correct?
Yes.
Okay. But you must not develop bad habits in mathematics. Meaning, when you're solving a problem, do not, unless you have to, do not use a previously calculated value. We are going to find circumstances in which we must use previously calculated values. But do not use a previously calculated value unless you have to. Why? Why do I say that? Why? Probably the answer before is wrong. What else? If it is not right. Sometimes by rounding off, you diminish the actual value. Okay? Although this is a previous error. So they will not penalize you for that. But it is always the best to ensure that all of your answers are correct. Then your presentation is going to be irrefutable. Alright, so we are about to find P, and we're not going to be using any previously calculated values. So we are going to be using the given values. By the time we get to sine and cosine rule, the triangles that we will be solving there will require that we use previously calculated values. At that stage, it will be unavoidable. But as long as you can, do not use a previously calculated value. Let's go. So we're going to say for P. Relative to the angle that is given, P is adjacent. What else is given? 10, which is the hypotenuse. Adjacent hypotenuse. Which trig ratio is that? Cosine. And cosine is equal to?
Adjacent over hypotenuse.
So, adjacent over hypotenuse is equal to cosine of 30. So, P is equal to, we are dividing by 10 here. We eliminate this 10 by multiplication. So, we have 10 plus 30. 0.866, and that is equal to 8.66 centimeters, and that is what P is equal to. So, as long as you are able to write one equation that contains how many unknowns? 1. You are able to solve your problem. Let's get along with it. Here's another one. Very nice. 18 centimeters. C up there. 40 degrees, and B, A is unknown right there, and Okay. Very nice. What do we find next? B. In this particular case, B is which side of the triangle? Hypotenuse. What is given? 18 centimeters. And what else is given? 40 degrees. So relative to this 40 degrees, 18 centimeters will be opposite. And B, what that we are attempting to find is the hypotenuse. What trig ratio is opposite and hypotenuse? Sine. And sine is equal to what? Opposite over hypotenuse. So sine of 40 is equal to opposite, which is what? 18 over the hypotenuse that we are attempting to find. Now students, I use a lot of strategies in mathematics. And one of them is not to be filled in with a calculator. Is it a calculator? Well, it has to be. Yes. Okay. I'm just going to show you a few little things. One of them is this. Whenever you are solving a problem like this that involves a fraction in which we have the unknown, if the unknown is in the numerator, you put it on the left hand side. If the unknown is in the denominator, you put it on the right hand side. And what you can do is design when you can design it, because by the time we get to the sine rule, you will see that you can design your unknown to be anywhere you want it to be. So you try to get it always in the numerator on the left hand side. Now, notice that when I have it in the numerator on the left hand side, we are dividing by 10. We just eliminate 10 by just multiplying here, correct? Right. In this case, we have it in the denominator, so we have it on the right hand side. So if we have it on the right hand side, we are dividing by b here. What do we do? Multiply by b, correct? And if we multiply by b, it will be where we want it, on the left hand side. So all that we need to do now is just divide by the sine 40. Now let us look at the alternative. 18 over b is equal to sine 40. We're dividing by b here. What do we do? We're dividing by b here. What do we do? Multiply. When we multiply, notice here it's gone already. Where is that? On the right hand side. So it will cause your work to be extended by at least another single step. Because it's just on the right hand side. So when you have it here and you make the first step in transposition, it is right there on the left. So we have what? B sine 40 is equal to what? 18. Don't use your calculator to do anything as yet. B is equal to what? 18 over sine 40, which is equal to 18 over 0.64. Alright. Now look at 18 and look what we have here. If you're going to do the calculation in your mind, because you should do that a lot when you're solving problems. Because sometimes you'll just do a calculation and go on a calculator and just put in some values and get something that is way out and you do not recognize. But if you look at this, if this is 18 and you're going to make a rough check, what would be the best number to be here that is close to this number that you have here? What would be the best number to make a rough check with 18? That is with this number, a number that is close to this number. What number would be close to this number that you could use to make a rough check? If this is 18. Let me repeat that. If you're going to make a rough check with a number that is close to this number here, what number that is close to this number that you would use to make a rough check will be 18? What do you say? That? Not 64. Take a good look again. But you are operating without recognizing that this is 18. Repeat that? 0.60. 0.6 will be a good estimation, right? Because it will do 0.6 will go into 18 30 times. So you can make a rough check. 0.6 will go into 18 30 times. But this is a little bit more than 0.6. So your answer should be a little bit less than 30. Because you're dividing by a larger number than 0.6. So your answer should really be less than 30. So you're looking at 29, 28, 27. One of those three numbers. I wouldn't go further than that. So you could probably check on your calculator out and see which one you get. 80 divided by 0.6 squared. Read that? Okay, 28. And we are about to find the C. C. We have the knowns, 40 degrees, 18 centimeters. We have discussed the 18 centimeters relative to the 40 degrees, and that we call the and hear that. Relative to 40 degrees, 18 is what? Opposite. We are attempting to find C, and its position relative to the one that we know is what? Which trig ratio has opposite and adjacent? Tangent to what? Yeah man, that's nice. Tangent, and tangent is equal to what? Opposite over adjacent. So, opposite over adjacent, you see already that the C is going to go in the denominator. So you're going to put that on the right hand side. So we have what? Tan 40 is equal to opposite over adjacent. So our transposition, this is analogous to this one. So we can solve by analogy. So we say what? C tan 40 is equal to 18. So C is equal to 18 over tan 40. Don't use your calculator yet until I say tell you what is tan 40. Tan 40 is less than, so it's 0 point. Check that out and see.
Yes, sir.
Is it? Okay. Alright. What can we do with this 18 to make a rough check? Something that close to 0.83. 0. What? This is 18. What would you use? Something that is not linear. Right, 0.9. And if you use 0.9, you're going to get 20. But this number is less than 0.9. So your result must be larger than 20. So you're looking at 21, 22, or 23. So what do you get? I would use 22. 22 centimeters. Alright. should be. But remember now that I'm writing it from, I guess so, 0.84. And this will turn out to be what? Closer to 21 now. 21 point. So that turns out to be 21 centimeters. Finally, your favorite. Twelve centimeters. 13 centimeters. Y, X, and W. What is the first thing that you will find here? The angle, which one is the easiest one to find then? The easiest one first. What do we find here? The square root of? Minus the square root of the square root of all of 13 squared minus 12 squared. Do we need to find the angle? Yes. Which angle are you going to find first? X. By saying what? This is X, this is? And this one is? Which regression is opposite and hypotenuse? You can hear that. Sin X is equal to opposite over hypotenuse. No. Rewrite. So what is X equal to? What is X equal to? Did you hear that? The sine of the angle is this one. So we need to define the angle whose sine is 0.93, 0.92. Which means that we need to take the reverse of taking the sine of the angle, which is taking the sine inverse of the angle. So x is equal to sine inverse of 0.92. Of course, you have those functions on your calculator. So x is equal to second function. Some of you have inverse, some of you have second function, and I don't know what is on the organizer. Yes. What did you have? 60 what? Okay, fine. That's nice. And what will be the other angle? So W will be equal to 90 minus 67, 23 degrees. So when you're on top of your game in mathematics, you're just waking up to it. When you're on your game in mathematics, you know that a 5, 12, 13 right angle triangle has angles 67 and 23. And you know that a 3, 4, 5 has what? 37 and 53. Right. And you know that those are not the only popular right angle triangles, but you have what? 8, 15, 17, and 7, 24, 25. Right. Alright. Yes. Over there is cold. Alright. Now sine of 30 is equal to 0.5. Right? Sine of 30 is equal to 0.5. But if we have the sine of 30 degrees, or we have a sine of an angle, and we do not know the angle. So we have what? Sine of y is equal to 0.766. Sine of y is equal to 0.766. So we do not know the angle, but we know the sine of the angle. So what do? We take the sine inverse. You can get something close to this. 9 what? Okay. No, I don't use to Alright, so that's that. Now students, although we're not going to do the topics today necessarily, we can take a look at it now. Yeah, in the computation too.